Okay, so did we actually discuss this trip from Sylvania to, we did, okay, good. Excellent, let's review graphing. Graphing linear functions. All right, the first thing is you should be able to recognize that this one is in slope-intercept form. Doki? When you look at this, you should be able to tell what your slope is and what your y-intercept is. Your parent doesn't want you on video. I'm gonna get in trouble and go to jail. Thank you. Probably not, but. Hello. Wait, what? Yeah. They have access to it. Really? All right, what's the slope? The slope should be? Your y-intercept should be? All right, so for graphing, what does the 2 mean? The 2 means that you're going to rise 2, run 1. So you're going to go up 2, run 1 to the right. Okay? So go to -4, and you're going to go up 2 units. So 1 unit, 1 unit, 2 units, and then I'm going to run 1. So right here. I'm going to go up 2 units and run 1. Here we go. There we go. Perfect. Okay. This one, y equals -2x plus 2. This one is also in which form? Which linear form? Slope-intercept. So you should be able to read your slope and your y-intercept from this diagram. All right? If you can't, I don't know if you cannot see, move closer, especially if you should have the packet with you. Your slope is? -2, and the y-intercept is 2. Now, what does this -2 mean? This -2 means that you're going to go down 2, and you're going to run 1, right? Because it's -2 over 1. So let's find our y-intercept, which is a 2. Find this one first. Okay. And we're going to go down 2, and then we're going to run 1. So 2, down 2 over 1. Down 2 over 1. You can keep going if you want to, but it's not necessary. You really only need 2 points. And then after that, you really just need some cats. See? To help you draw the line. Especially those of you that still haven't mastered this. This is now like knowing your numbers and knowing your math facts in this level of algebra, of math. All right, let me do one more. When you look at this one, what's the slope? All right, it's +1/2. That means you're going to go up 1 and you're going to run 2. With y-intercept being -5, 1, 2, 3, 4, -5 right here. We're going to go up 1, run 2, up 1, run 2. There we go. Okay. All right. All right, the person chatting, please don't. It's Friday. There's no need for parent emails. Come on. All right, so this is the formula sheet. Let me find, this is the correct version of Desmos that you should be using because it says grade 8 and the high school version right here. Okay? All right, so when we look at problem number 5, it says graph number 5. What do you notice about the form? Is it slope-intercept form? It's standard form, right? And yes, there are ways of doing it in standard form. Make one 0, calculate the other one, blah, blah, blah. But that was that's something that we should master. You can just do it in Desmos. Look, you just gotta type is 2x minus 5y, and I'm recording this. You have access to it. Are we clear? You're like, how did she type it in? Oh, let me open up the video and figure it out. Let me be self-sufficient. And as you can see with Desmos, all you have to do is click y-intercept. You see it's gray right now, but if you click on it, the number stays. So I'm writing on my graph right here. I don't know what I'm writing. I guess I'll write those numbers down because I'm going to need them later on. So I'm going to plot a point at 0, -2, and I'm going to plot a point at 5, 0. And then I'm going to use my cats to draw a line. See? Looky good? Alrighty. All right. Now, I'm going to focus on this graph and this graph only. Because look, y equals 2x minus 4. We graphed it already. Yay! Excellent. And look, they already did the work for us. If they ask you for the y-intercept, what are you going to say? Why aren't you writing on your graph? Let's go. Your graph, you can split it. You can, yes, you can undo it. That's fine. The stapler. All right. The x-intercept is 2, 0. And it's literally just looking at the graph, okay? The slope is 2. We knew that from the equation. Let's do the ones we know. Domain. Excellent. All right, domain. They use a new form of notation here. Let's think about it ourselves. Are you going to be using x's forever? Or does it stop at 4? Do I need x's that are higher than 4? What does that arrow mean? Does the function continue? If the function continues, it needs more x's. You cannot have a point without an x. Are we clear? So the fact that the function continues, that means that you're going to need x's forever. X's forever is called what? Now, can my x be 1? Yes. 0, x -1, x -2. How about x -3? Do I need x equals -3? Yes. Okay. It stops at 0. No. When x equals 1, what's the value? When x equals 0, what's the value? When x equals -1, what's the value? -6, something like that? And when x equals -3, what's the value? All right, we don't know what it is, but there is a value, yes or no? How do we know that there is a value? There's an arrowhead. That means it's going to continue. If the function continues, then you're going to need an x. Is there such a thing as an x and y point, an ordered pair that doesn't have an x? No. Even the origin has an x, which is 0. So, yes, you're going to need all the negative x's that you can get. Negative infinity. So your domain is any x value. All the values in the real number set, from negative infinity to positive infinity. That's how we understood it when we were talking about it before. That's how we are going to write it. The domain is negative infinity to positive infinity. Okay. Now let me teach you what they are writing over here. This says that the domain is x values such that, that's what the line means, the x values are in the set of all real numbers. So, what do you mean lost? Did you understand negative infinity to positive infinity? Okay. All right, I understand now. All right, so they're writing it in this form. I'm just trying to explain to you what this means, okay? This X, this E, just means set. And the R represents all real numbers. So your X's must be in the set of all real numbers. What's a set of all real numbers? Any number that qualifies as a real number. Remember rationals, irrationals? Yes or no? Yes. Fractions, all of that stuff is real. Any of those can be values for your X. So basically from negative infinity to positive infinity, any X value there. All right, the range. Now let's talk about this. If the function goes up forever, are you going to keep on getting positive y's? Positive y's forever. Clear? Join the club. If your function keeps on going down forever, are you going to keep on getting negative y's? So negative infinity. So your output, your range, is going to be any y value, positives and negatives. So we say from negative infinity to positive infinity. All right. This is another way of writing this. Same thing, except instead of saying x, I'm going to say y. Y values such that the y values are in the set of all real numbers. Fancy math. And behavior. When we talk about end behavior, we're asking which way is the arrowhead going? Clear? All right, as x is going to positive infinity in this case, clear? As your x's are getting bigger, what's happening to your function values? They're increasing towards positive numbers, correct? Yeah, so as your x's become more positive, your y value, so your function is becoming more positive. That's end behavior. How do they write that? They write it right here. As x arrow approaches infinity, the function f of x is approaching positive infinity. So as x becomes more positive, the y's become more positive. See? X becomes more positive, the y's become more positive. Now what about the other end of the function? What happens when your x's become more negative? What happens to the y's? They become more negative because it's going down. See? That's the end behavior. So they write it down. As x goes to negative infinity, the function values also become more and more negative. Now I'm going to teach you something, and you better remember this. All of this is going to stay the same. That will be rewritten over and over again. The only thing that we fill in is this right here. All right, or they might backwards ask you. All right. In which direction is the function, but they probably won't. End behavior, they're very straightforward about this. Okay, that's the answer. As x is becoming more positive, what are the values of the function becoming? Yeah, positive infinity in this case. Okay. All right, let's do it again, but with the one with the negative slope. Y'all remember we graphed this one? Wait, I know. What is this? I'm sorry. It's this one. Y'all remember y equals negative 2x plus 2? This one had a negative slope, right? Let's talk about the end behavior. Okay, in the front, right here. Thank you. As your x's are becoming more positive, what are the values of your function becoming? More positive or more negative? So as your x's are becoming more positive, the value of the function is becoming more negative. And now, what's happening to your function as your x's are becoming more negative? What are the values of the function becoming? More positive or more negative? Positive. Yeah, they're going up. So these are positive y values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Keep going. So this is a different end behavior. They have opposite end behaviors. As x is positive, this one becomes positive. This one, as x goes positive, the function becomes more negative. You see how their end behaviors are different? So that's what we want to know. That's what they're going to ask you. That's what they want to ask you. As x goes to the front, right here, front. No more disruptions, guys, please. If you got a question, ask a question. All right, so let's do it for this graph right here. Everything. You can rip the paper, you can look at my graph, whatever it is. Here we go. Do we know the y-intercept? What is it? 2. If I write that as an ordered pair, what would it look like? 0, 2, correct? What's the x-intercept? 1. Or if I write it as an ordered pair, what would it look like? 1, 0. All right, what about the slope? What's the slope of this line? The x-intercept is 1. X is 1. Isn't it 1 right here? It's crossing the x-axis at 1. What's the slope of this function? What is it? Negative 2 over 1, or we just simply say the slope is equal to negative 2. Okay. There you go. You just got 3 questions right. Now, let's go to the stuff that we can do. Since we just did end behavior, let's write it down. Now, remember what I told you. Everything that's in yellow gets rewritten. You don't change nothing. Can we do that for me? All right, let's go. You don't need to copy me because it's right in front of you. Just copy what's here over here. All I'm doing is copying. Okay? I just need to know how to read it. All right. Once again, you don't need to raise your head. You can just copy it from your own paper. All right, everybody done copying from their own paper? All right, so now we said as x goes to positive infinity, that's over here, which way is the function going? Which way is the function going? Let's read it. Negative infinity. Put it together. Don't just be negative. Don't just be infinity. It's going towards negative infinity. Okay. Now, we said that as the x's are more negative, the value of the function is becoming, okay, and we call that positive infinity. Clear? You can put the plus sign if you want to, but it's unnecessary. That's it. And like I told you, that's literally the only part of this that we're answering, okay, for end behavior. Everything else is on the right-hand side, which way is the function going? On the left-hand side, which way is the function going, okay? All right, domain and range. Now, since this function goes down forever, are you going to need x's forever? Yes, you cannot have a line if it doesn't have a point. Point needs an x and a y. Okay, so the domain is, wait, we only did one side. How about the negative? Do you need negative x's? Forever? For the input, yes or no? Domain and range are really hard, so here we go. Domain is going to be negative infinity, positive infinity. Now let's talk about what y's do we get from this function. Does this function give us a value of y equals 1? Say it loud and clear. Come on. It's either yes or no.
No.
Okay. The answer is yes because it's right here. When x equals something, it gives us a value of 1. Okay? Yes or no? Yeah? I'm not trying to trick you. I'm just being honest. Can x be 1? Wait, I asked it wrong. All right. Can we get a y value of 2? What is the x value when y equals 2? 0. Can we get a y value of 3? Right? That's like -1, I think, or something like that. So y can be 4, y can be 5, y can be 6. Is there a stopping point? No. So for the range, you can get any y, which means your y's can go as high as positive infinity. Now, can you get an output of y equals 0? We said yes. Can we get an output of y equals -1? Yes, right here on the line. This point right here, whatever x that is giving us a -1. Can we get an output, a y value of -2? Yes. Right? When x is 2, y is -2. Can we get a y value of -3? Yes, right here. Can we get a y value of -5? Yes, because there's a line. Does the line ever stop? So that means you're going to need y. You're going to get y's forever negative. There's no stopping point. Just like it gave you -1, -2, -3, -4, -5, it's just going to keep going. So since that's a lot of numbers to write in math, we say negative infinity. And that just means it's going to get as negative as it can possibly get. And since there's no end, there's no location for infinity, it just keeps going. All right, how do we say what the function values are going to be, the range? The range can be y values, any positive values. So we say the range can go from negative values to positive values. Oh, we're almost done. Now, we didn't look at positive and negative. New material. Some of you might have seen it already on the homework. Where is the function positive? Here we go. We're going to look at the first one first. Okay, the graph is -4. Where on the function do I get positive y's? Here, correct? Okay. So technically speaking, you're going to get positive y's or y's greater than 0 when the function is above the function you're writing. I'm breaking it down for you. The function is above the x-axis. Your y values will be positive when the function is above the x-axis. Make sense? Okay. Now, how do we answer this question? When they ask you, hey, where is the function positive? You need to identify at which x does it start. What's the x value here? All right. X is positive when it starts at 2. They're positive when x is 3? Or no? Right. This is quadrant 1. Y'all remember quadrant 1?
Yes.
What's one characteristic about quadrant 1? Both of them are going to be positive, right?
Yes.
So when x is 3, the y is going to be positive. When x is 4, the y is going to be positive. Anytime the function is above the x-axis, it's going to be positive, right? So, and we say x goes to infinity, right? So how do we say all the numbers that are bigger than 2? It's just going to be x is greater than 2. Anytime x is greater than 2, the function is going to have a positive value. It's going to be above the x-axis. This is the function, correct? From this x right here and going this way when the function is positive. Now, where is the function negative? Where is the function below the x-axis? Right here. 2, 2, 2. All of these are going to give negative y's. Guys, I know that this is very abstract, but we're just learning the raw math. Remember when they were just teaching you how to add numbers?
Yes.
And it was just adding them. There was no purpose to it besides what's 2 plus 2. And then they started teaching you, hey, if we have 2 apples and we have another 2 apples, how many apples do we have in total? There's an application. So right now we're doing the raw math. And you cannot do the applications if you don't know how to do math. Clear. So let's pay attention to the basics so that when we start going into the Sharon went to Atlanta and blah, 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 and they start asking you about where was the function negative, you can answer it, okay? So over here where you're going to negative y values, from which x value are you getting negative values? All of these x's are smaller than 2. How do we write values that are smaller than 2? Right here. The answers are already on the paper, people. X is less than 2. All right? All right, let's look at the other graph now. Where is this function above the x-axis? All right. Let's do this. Is the function positive, the output positive here? Here? You're always going to have positive, even though the x is negative, the y value is positive. We're talking about the output of the function. Okay? It starts at which x value? 1. How do we write all numbers smaller than 1?
Wait, no, x is less than.
No, okay. X is less than 1. The function has positive y values when x is less than 1. What's the y value when x is 0? Positive 2. You see? So on and so forth. Anything less than 1 is going to give you positive y's. Now, below the x-axis is when your function is negative. Which x values give you negative outputs? Numbers that are greater than which x value? 1. So x has to be greater than 1. All right, now I'm going to convert for you guys between, this is inequality notation. We're going to put it in interval notation. How do we say numbers that are greater than 2 as an interval? We say, well, they start at 2 and they keep going forever. Those are numbers greater than 2. How do we write in interval notation numbers that are less than 2? All right. Negative infinity, comma 2. Is that the bill? Close, put it away. A1, A2, A3.